In this video, we will talk about the main process that occurs in the formation of stars, which is the merger of gas and dust in space, and how this merger can lead to the formation of a new star. At the end of the video, you will be able to understand how stars form and how they can greatly influence the formation of the planets we know and live on. Stars are formed from the elements hydrogen, helium and other heavy elements in the universe, by a process called nuclear fusion, in which atomic nuclei fuse at extreme temperatures and pressures to form a larger and heavier core. This process releases huge amounts of energy, and this energy is what gives stars heat and light. The lifespan of stars varies based on their mass, with larger stars burning faster and depleting their energy in only millions of years, while small and medium stars burn slower and live for millions or billions of years. And when the star runs out of all its energy, it collapses and explodes in what is called the Great Nuclear Explosion or the Great Stellar Explosion, and it turns into a neutron star or a black hole. Stars influence the formation of planets through the formation of dusty disks around young stars. Dust and gas collect in these disks and form planets. The temperature of stars varies based on their mass and age, with the temperatures of larger stars being higher than younger stars, and the temperatures of young stars being higher than urban stars. This affects the temperature of the planets that form around the stars, where the planets of the hottest stars are usually closest to the star, and turn into dry rocky planets, while the planets of the smaller stars are cooler, and planets such as Earth are formed and it is possible that there is water on them. Stars are formed from gas and dust in space, by a process called gas collapse. This process begins when gas and dust gather in a specific region in space due to mild gravitational effects. With the passage of time, the size of this gathering area increases and the concentration of gas and dust increases, which leads to an increase in gravity and an acceleration of the gathering process. When the gas and dust reach a sufficient mass and its temperature reaches a certain level, the process of nuclear fusion is initiated within the gathering region. This process occurs when hydrogen atoms collide with each other and turn into helium, and this process results in enormous energy that the star spreads in all directions. This internal rotation of the star continues for several million to billions of years, as the nuclear fusion process continues inside it and the star emits heat and light. And when the star runs out of all its energy, it collapses on itself and explodes in what is known as the Great Stellar Explosion or the Great Nuclear Explosion, and then turns into a neutron star or a black hole according to its mass. The duration of the star formation process varies depending on the size of the star and the amount of gas and dust available in the region where the star is forming. Star formation can take several million to hundreds of millions of years. For example, very large stars that weigh more than 100 times the mass of the Sun need millions of years to form, while small stars that weigh about 0.1 times the mass of the Sun need millions of years as well, but in this practical case it takes a much shorter time. In addition, the process of star formation also depends on other factors such as the density and temperature of gas and dust, the amount of gravitational energy present in the area, and external influences such as waves from other stars and cosmic nuclear explosions. Therefore, the duration of star formation may vary from one star to another. In general, it is believed that young stars do not reach enough mass to become neutron stars or black holes, and instead end their lives by turning into a white star. However, this depends on many other factors, such as the composition of the star and the rates of nuclear fusion within it. And the transformation of young stars into neutron stars or black holes can occur under certain conditions, such as the interference of stars in a binary system, or exposure to the strong gravitational effects of other stars or other cosmic phenomena. It is important to note that larger stars are more likely to become neutron stars or black holes, because they have more mass, generate more energy, and are subject to more gravitational influences. Stars are among the largest and most massive space objects in the universe, and there are many large and huge stars, but I will show you in today's video the 5 largest stars in the universe. 1. Betelgeuse star. It is one of the largest stars in our Milky Way galaxy, and is considered one of the brightest stars in the sky. 2. Orion star. It is one of the largest stars known in the universe, with a diameter of about 1800 times the diameter of the Sun, and it is located in the constellation of the Great Dog. 3. Mossfett star. It is a red giant star located in the constellation of Cape, and it is one of the largest known stars in the galaxy. 4. Antares. It is a red giant star located in the constellation of Scorpio, and is considered one of the largest stars in our galaxy. 5. Rigel star. It is a blue star located in the constellation of Orion, and is considered one of the largest known stars in the galaxy. There are many other large and massive stars in the universe, and their sizes, features and characteristics differ from each other. Thus, we know everything about the stars and how they were formed. Do not forget to click like the video and subscribe to the channel, and we will see you soon.